scientists have discovered a portal to the fifth dimension. Firstly, you might want to know what the fifth dimension is. Before we get to that, it is safe to say that if there is a fifth dimension, then there are another 4 dimensions before it. These 4 dimensions are related to volume. Like your high school math textbooks have suggested, they are length, breadth, and height. That's the first 3, and Einstein added the 4th later. It is simply time. So length, width, height, and time comprise the 4 established dimensions. And the 5th dimension, which is being proposed, has more to do with electromagnetism and gravitation. The theory that supports this 5th dimension has yet to be finalized, but it involves an undocumented particle that can operate within it. The hypothesis is that this new and strange particle will enable scientists to understand dark matter a little bit more. The existence of this particle and the 5th dimension as it relates to dark matter have been observed somewhat, prompting scientists to make a calculated guess. In this video, we'll try to explain these discoveries, so stick around. Welcome to our channel, where we provide you with facts related to space. Before heading on to the video, make sure to like this video, subscribe to the channel, and hit the bell icon so you may never miss any of our updates. Traditionally, we see the world and existence in 3+1 dimensions. That is volume or space in addition to time, or in other words, left to right or up and down plus the past and the future of time. Einstein first put forward this theory, and it has withstood all scrutiny even until today. However, in 1920, 2 physicists, Oscar Klein and Theodore Kaluza, attempted to improve on Einstein's theory of relativity by observing how mass had a stronger than normal effect on 4-dimensional space-time. They proposed that even though we cannot touch space or time, we feel them through the forces of gravity and, to a lesser degree, electromagnetic forces. To add to this hypothesis, in 1999, Lisa Randall and Raman Dundrum proposed that a 5th dimension could also help explain dark matter. Again, this was a calculated guess. Dark matter makes up most of the bulk of all the stuff in the universe, and this invisible entity accounts for 6 times more than the amount of matter that is visible. It also continues to pose a big riddle to modern scientists. As recently as 2021, researchers at the Gutenberg University in Mainz, Germany, proposed that the extra gravity that may come from dark matter has its origin in a 5th dimension. This same 5th dimension is where dark matter operates, and it manifests in our known 4-dimensional space with particles that are observable but not yet documented. In other words, there are new and strange particles that pop up, rendering the already existing theories wrong. Aside from these undocumented particles, dark matter may also be found in several entities like black holes, axions, and even reverse time from the future. That last one sounds like science fiction, but it is not trivial. The particles in question are called fermions. And how do they relate to dark matter? Scientists have observed that fermions can travel between our 4 known dimensions and the yet-to-be-discovered 5th dimension, and that the so-called fermions might be the driving particles behind dark matter. However, like the 5th dimension, dark matter has never been pinpointed or measured. Dark matter holds up the universe, yet little is understood of it. But what scientists know is that it is mostly inert and doesn't ruin other forms of known matter. For scientists, dark matter is like an invisible skeleton without which the theories about space cannot stand. Scientists can't touch this same skeleton, nor can they figure out its properties. All they know is that it exists. This is where fermions come in. They are like the Higgs boson, but are supposed to be heavier even though they have never been seen in reality. It might interest you to know that the Higgs boson was hypothesized 66 years ago, long before the Hadron Collider was built to actually find it. But in the case of heavier fermions, they would have to be found some other way, because the Hadron Collider wasn't built for the fermion particle mass, nor can any new collider be built. Such a collider is near impossible to build, all things considered. But if fermions can travel between dimensions as observed, then they can help us understand dark matter better. As mentioned, dark matter cannot be measured or observed. This is why it is important to prove the existence of fermions, and by extension, their 5th dimension traveling capabilities. Other theories trying to explain or measure dark matter have fallen short. short. However, this new theory involving fermions and a fifth dimension seems promising. That is because it satisfies the fundamental questions within the known framework. It is also easier to prove than the other theories, which are only wild guesses at best. All the new theory requires is a more sensitive gravitational wave detector to measure its prevalence. When discovered, this theory will turn the existing theories of the universe on its head. But first, the so-called fermions must be isolated, which is just the first step. They then have to be shot through the warped extra dimension, or, simply put, the fifth dimension. The expected result is that this experiment will exhibit properties of dark matter, and in that way, scientists can unify the theories of the universe. It's easy peasy, really, and it's the most natural way of all the others to prove that there is indeed dark matter. Scientists have even gone ahead to create equations and calculations that take a five-dimensional universe into account, pending the discovery of fermions. It is believed that these particles can open a window or portal into a fifth dimension where dark matter properties operate more freely. In short, fermion particles represent the most viable connection between dark matter and the matter we can see. They could be the messengers scientists have always sought into the realms of dark matter. So fermions are like a probe into dark matter, and scientists will be astounded at what they might find. The experiments done so far show no conflict between what scientists already know about dark matter. Even so, all the mathematical calculations regarding this new direction have checked out, and trust us when we say it has all been rigorous and robust. So the hypothesis is in place, and the quest for fermion particles alongside the fifth dimension is now open for business. It would require as much as 100 TeV of energy to achieve this using whatever existing colliders we already have. Some new generation colliders apart from the Hadron Collider have been proposed and are already being built. Still, those might fall short of the energy requirements for finding the fermion particle. The only other option scientists are left with is to find the fermion particle indirectly via the observation of gravitational waves. Moreover, scientists hope that, in time, advances in particle physics and cosmology will shed more light on this new theory. And if they are right, this could be a game changer for other ideas relating to quantum physics. It is thought that in the fifth dimension, gravity and electromagnetism combine as the main property of dark matter. And while this theory might not necessarily be groundbreaking when eventually proven, it would take the scientific community a step further. For clarity, only fermion particles are allowed into the warped extra dimension, or WED for short. In the process, these particles create dark matter as they jump through the dimension, or so it is argued. The fermion particles are also dark matter's way of giving back. The gravitation pulls we seem to experience from the predominant dark matter surrounding us may in fact be found in these same fermions. During the experiments up to this point, new behavioral properties were discovered that could only have come from fermions in the warped extra dimension, as compared with the five-dimensional mathematical equations. The results are why this theory is so promising. The best thing of all is it could make dark matter more accessible for experimentation, and it proves dark matter and visible matter can react with each other, or at least fermions are the catalyst to make that happen. But first things first, the fermion particles have to be found. Quantum physics is an extremely complex field of study, and there is still much to be discovered and explained. It almost feels like dark matter itself, which occupies 75% of the universe, and yet we know little of it. So praise goes to the scientists for wanting to understand these phenomena better. In this video, we have treated just one aspect, but suffice it to say, this represents the most current development in quantum physics, the last time we checked. But physicists at large will surely make more findings, and hopefully, the discovery of fermion particles will open more portals to other ideas. Thanks for watching. Feel free to drop your comments on what you think, and be sure to click on the notification button for more updates. See you in the next video. Bye.